Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in to this video on graphing straight lines. So we're looking at the relationship between two variables. Here, x and y are the variables. We're looking at how does y change each time x changes. So as you can probably guess from the word lines, we're looking at linear relationships here. So the relationship between x and y is linear if each time x goes up by 1, y does the same thing each time. It goes up or down by the same amount. So we only have 2 points here. So x to go from here to here has gone up by 3, and y has gone up by 9. So 9 over 3, which is the change in y, divided by the change in x, also known as rise over run. We usually denote m, and that term you're probably familiar with is the gradient. So the gradient here is 9 over 3, which is equal to 3. So that means each time x is going up by 1, y is going up by 3. So we can fill in the rest of this table. So that's what a linear relationship means. There's a constant gradient. Each time x is going up by 1, y is going up by, in this case, 3. And that number that y goes up or down by each time x goes up by 1 is called the gradient. So this relationship is said to be linear because if I were to plot all of these points in the Cartesian plane, they would fall in a straight line. So the relationship between x and y here can be stated as an equation. Here, y equals 3x plus 10. Now, it's no coincidence that this number here, 3, is the same as this one here. We can write any linear relationship, unless it's a perfectly vertical line, which we'll discuss later. We can write it as y equals mx plus b, where m is the gradient and b is the y-intercept. It is the y value when x equals 0. And as you see here, this number here, 10, is the same as this one here. So an equation is linear if it can be written in that form. It basically means the powers of x and y are 1. There's no x squared term or square root of x term or whatever. So when you graph this equation, what you're graphing is all the possible solutions to this equation. If we have an equation like y equals 3x plus 10, there isn't just one solution because there are two variables. X equals minus 2, y equals 4. That is a solution to this equation, as is x equals minus 1, y equals 7, and so on. So each of these possible solutions is a point in the Cartesian plane, and it turns out that because the relationship is linear, all of those points will lie in a straight line. And that straight line is what you need to draw when you're asked to graph an equation. So I'm going to give you two methods and then show you, I guess, some pathological cases at the end. So it turns out if you have any 2 points in the Cartesian plane, there will be one and only one line that goes through them. So the methods I'm going to show you involve finding 2 points that lie on the line and joining them up. So let's get started on that. So the first method for graphing I'm going to show you is the gradient intercept method. And that's easiest to use when your equation is in the form y equals mx plus b, because m is the gradient and b is the y-intercept. You don't have to do any work to find out the gradient and intercept. So we follow these 3 steps. So let's look at some examples. We have our Cartesian plane here, and we're going to start by graphing y equals 4x minus 3. So this is in the form y equals mx plus b. The number in front of x is m, that's the gradient, and the number by itself is the y-intercept. So b here is not 3, it's negative 3. So we follow the instructions above. We mark the y-intercept, which is minus 3. And then we use the gradient to find a second point. So the gradient here is 4, which is 4 over 1. So the bottom number tells you how far you go to the right, and the top number tells you how far you go up or down. You go up if it's positive and down if negative. So I'm telling you always go to the right. So 4 over 1 means we go 1 to the right, which is here, and then we go up 4 because it's positive to there. That is our second point. Now all we need to do is join them up. So this line here in black is the line y equals 4x minus 3. So now we're going to graph the line y equals 1 minus 4 over 3x. So things are written in a different order, but the gradient is still the number in front of x. So here the gradient is negative 4 over 3, and the y-intercept is the number by itself at 1. So we're going to do exactly what we did in the previous example. We mark the y-intercept. Now the gradient is negative 4 over 3. So I said the bottom number tells you how far you go to the right. So I'm going to go 3 to the right, which is over here. But because this is negative, instead of going up 4, I'm going to go down 4. So I'm going to end up down here. So they are the 2 points on the line that I've graphed, and now I simply join them up. I join them up, and there we have the graph of y equals 1 minus 4 over 3x. So don't forget to put arrows on your lines to indicate that they go forever in both directions, and also to label them with the equation. So as I said before, any point that lies on this line satisfies the equation. For example, we can see the point 3 minus 3 lies on the yellow line, because if I substitute x for 3 and y for minus 3, I get minus 3 equals 1 minus 4 over 3 times 3. That is a true statement. If I substitute the value of x and y into the equation, I get a true statement. So that's why 3 minus 3 lies on the line. You'll see, for example, that 0, 0 does not lie on the line, because if I substitute x is 0 and y is 0 into the equation, I get 0 equals 1 minus 4 over 3 times 0. Left-hand side is 0, right-hand side is 1. That's clearly wrong. That's not true. So 0, 0 doesn't lie on this line. All right, let's look at the second method. Please pause and copy this down if you need. So the next method we're going through is called the XY-intercept method. So let's say we have an equation like this. So let's say we have the equation 3x minus 4y equals 12. Well, that too is a straight line, but it's not in the form y equals mx plus b. So this number in front of x3 is not the gradient, and this number here, 12, is not the y-intercept. Now, we could write this equation, we could rearrange it into the form y equals mx plus b to find the gradient and the intercept, but sometimes that gets a bit messy, and it's probably worth our while using a different method. And that's what the xy-intercept method is for, when you have it in this form here. Something times x plus something times y equals something. So what we're going to do to graph this is let x equals 0 to find the y-intercept, and then y equals 0 to find the x-intercept, and then plot them up. Once again, we're finding 2 points. It just happens that in this method, the 2 points we find on the line are the 2 intercepts, where it hits the x-axis and where it hits the y-axis. So let's start by letting x equal 0 to find the y-intercept. So if I let x equal 0, this term here will disappear because it's just 0. So I'm left with negative 4y is equal to 12. Divide each side by negative 4. The y-intercept is minus 3. So second step, now if I want to find the x-intercept, I let y equal 0. So this whole term here is going to go away. I'm left with 3x equals 12. Divide each side by 3. X is positive 4. So the y-intercept here is 3. The x-intercept is 4. I simply plot them and join them up. How easy is that? Now I've plotted with the black dots the x and y intercept and just draw a line through them. Because I've now labeled the line with arrows in the equation, I'm done. I just want to make the point that if the line leans right as it does here, that means the gradient is positive. That means when x is increasing, y is also increasing. And if it leans to the left, that means the gradient is negative, which means that when x is increasing, y is decreasing. So now I just need to show you horizontal and vertical lines. Please pause and copy down this information if you need it. So take care when graphing horizontal and vertical lines because they sort of go in the opposite direction that you'd expect. So y is the vertical axis, but if the line is of the form y equals a number, like y equals 2, then that line is perfectly horizontal. It's parallel to the x-axis. And if the line is of the form x equals a number, like x equals 3, it's vertical and parallel to the y-axis. So it turns out that if the line is horizontal, then its gradient is 0, and if a line is vertical, its gradient is undefined or infinite. So hopefully you're now starting to see why we couldn't use the previous method, the XY intercept method, because these lines only have one intercept, so you can't get 2 points from them. Of course, we couldn't use the first method, gradient intercept method, on lines like this because it doesn't actually have a gradient. So just remember this rule. So let's look at a few simple graphs. So let's say I want to graph the line y equals 3. Well, that's really easy. It has a y-intercept of 3, and it's a perfectly horizontal line. So y equals 3 is this line in green. Pretty simple. Now let's graph x equals -2. So that's simple. You just have an x-intercept of -2, and it's a perfectly vertical line. And that is the graph of x equals -2. So these lines are pretty simple to graph. People just get tripped up by them by trying to use one of the other methods, but you won't make that mistake now. All right, this has been the luckiest maths teacher in the world. Have a great day.